from the R.K. Bali book. The distance around the Earth along the equator and around the meridian and anti-meridian will be how much? Will it be the same? Will it be along equator more than meridian and anti-meridian? Around the poles, will it be more? Now they have asked you about distance and around the Earth. That is, and they have given two options: equator, meridian, and anti-meridian together. Meridian and anti-meridian together. So let's look at this. Here we have the equator. Let's look at the equator first. Okay. Now equator is a 0 degree latitude. And by definition, equator is also a great circle. What is a great circle? Any circle on the surface of the earth whose center is the same as that of the earth, okay, and which divides the earth into two equal parts. And the third property of a great circle will be that any points, okay, if you want to travel between any 2 points, the great circle arc will give you the shortest distance. So if you want to go from A to B, okay, and if there is a great circle joining A and B, it will be highly beneficial and profitable to travel between A and B using a great circle route than using any other route like a line route. So a great circle route always gives you the smallest distance between any 2 points. Between any 2 points. Okay. So equator is a great circle. Okay. The full 360-degree equator is a great circle. Now let's check the meridian and anti-meridian. Now we have done in previous lectures in which I have often talked about this, that a meridian for itself. Let's say this is your meridian. This is your south pole. This is your north pole. Now let's take this meridian, just this meridian from south to north in one part of the hemisphere. Let's say eastern hemisphere. Okay, this meridian alone will be your rhumb line. This meridian alone will be your rhumb line, depending on which direction you go. So if you go from south to north, the direction of your flight will continuously be northerly, correct? Will continuously be northerly. That means, by definition, this meridian will be a rhumb line. What is a rhumb line? Rhumb line is any line with a constant direction. With a constant direction, right? So by this definition, when you start from Sierra, that is S, go to point N, you will be flying a rhumb line path. Now when you cross this North Pole and you continue your journey on the anti-meridian of this meridian. So the anti-meridian of this meridian will be this dotted line, correct? Will be its exact anti-meridian. And if you continue your flight beyond North Pole, you will be flying southerly heading. You will be flying what kind of heading? A southerly heading. So beyond North Pole, directly your magnetic compass will switch its direction 180 degree, and now all of a sudden it will start pointing towards South Pole because you have crossed the North Pole and now you are automatically following this anti-meridian and going towards the South Pole. That is the reason why it will point towards South Pole. So this anti-meridian again separately is what? This anti-meridian separately is what? It's another rhumb line. This meridian separately is one rhumb line. But meridian and its anti-meridian together they won't be called a rhumb line. Okay, because the direction here is northerly, whereas the direction here is southerly. So together, both meridian and anti-meridian together won't be called a rhumb line, but separately, each of them is a rhumb line. Okay. So this is about rhumb line. What about great circle? By definition of great circle, just like equator, a meridian and its anti-meridian together, when considered together, will form a great circle. When considered together, will form a great circle. But considered together, they won't form a corresponding rhumb line. But when considered together, they will form definitely a great circle. So in such a way we have 180 meridians, 180 anti-meridians for them. So every meridian and anti-meridian will be a great circle. Okay. Common center of the earth, also divide the earth into two parts. So according to this question, the distance around the earth along the equator and meridian and its anti-meridian will be exactly the same. Along the equator is more, around the poles is more. So it will be exactly the same. Exactly the same. Next part I want to explain to you is that for that I will need a new slide. So over here. Now the shape of the earth. Okay, it is very important to understand distances, the concept of distances. It is very important to know this concept of the shape of the earth. The shape of the earth, in other words, shape of the earth shapes our decision to select a particular route which will give a shorter distance or the shortest distance between two points. Now, a shape of the earth is something like this. It is compressed at the poles and bulging at the equator. Okay, so this is not an accurate diagram, but for understanding. So it is compressed at the poles. That means from both the poles on the top, it is flat or flattened or compressed. So it is compressed at the poles, but at the equator, it is bulging. Okay, it has spread out. Okay, this is what is the shape of the earth. We call it oblate spheroid. It's not a perfect sphere, but it's called oblate spheroid due to this unique shape, flattened at the poles on both poles, whereas at the equator it spreads out or it bulges outwards due to centrifugal force created by the rotation of the earth around its polar axis. And as you can clearly see that traveling around the equator will be definitely more. The distance traveled around the equator will definitely more than distance traveled from poles to poles, right? Because from poles to poles, from both the poles, the earth is flattened, so the distance between two poles will be shortened. But at equator, the points between two ends of the equator, like here, will be very far away from each other because the equator is bulging. So traveling from this point to this point around the equator will be much more compared to traveling from north to south along this meridian. Okay, so always selecting a route at along the equatorial plane will be a longer route than selecting a route which passes through the North Pole or which passes around the South Pole. Okay, that's why we will see, you must have seen in departure Ramline Great Circle chapters that always a great circle tracks. Okay, a great circle track is always known for its advantage that it gives the shortest distance between any two points. And this great circle tracks, if you are in the northern hemisphere, will pass through the nearest North Pole. If you are in the southern hemisphere, it will pass around the south pole through the nearest pole, which is the south pole. Okay, so in traveling near the south pole, it opts for a shortcut, and it takes you to your destination much earlier and quicker, saves your time, money, and fuel. Okay, so that's why great circle routes always go near the north pole or south pole, because when you travel through the north pole or south pole, you have to cover much shorter distance compared to the equatorial distance. Okay, between same two longitudes, but the distance between two longitudes at equator will be more than the distance between same two longitudes at the poles. Therefore great circles tend to fly near the poles. So coming back to this question, understanding that equator is a great circle, concept of Ramline and great circle applied to a meridian and anti-meridian, and then considering the shape of the earth as we have seen here, we are in a better position to answer this question that the distance around the equator will be more than the distance around the poles. Okay, traveling along a meridian and anti-meridian, only and only because of the shape of the earth. Let's go to next question. Question 2. The question number 4 of RK Bali. The earth rotates about its dash. Okay, so the earth rotates around its own axis and the earth revolves around the sun. Both are different things. So it rotates about its polar diameter, equatorial diameter, sometimes around pole, sometimes around equator. So definitely this cannot be the option. Now every time when we discuss about the rotation of the earth, we always say that when considering the earth rotates in anti-clockwise direction when viewed from the north pole. This is your north pole. So when viewed from the north pole, the direction of rotation of the earth is anti-clockwise. When viewed from the south pole, the direction of rotation of the earth is always clockwise. Okay. So with regard to this statement, the earth rotates around its polar diameter. Around its polar diameter. The earth rotates around its polar diameter. Always remember that. Okay. Right here. So we have this side view of the earth and we have the top view of the earth. So we have axis passing to the north pole and the south pole. So the earth will rotate from west to east around its axis, and then viewed from the top position, that is from the north pole, let's say. So the same view will be anti-clockwise when going from west to east. And this tells us that the earth rotates about its polar diameter, not the equatorial diameter but polar diameter. Let's go to question number 5. The cardinal points. What are the cardinal points or cardinal directions? So direction, distance, speed, time, these are basic four elements of navigation. Okay, in planning your flight, in planning your cross country flight, always there will be a track direction, distance between two points, the speed you are taking, and the time that will be spent in traveling from one point to another point. When you know time, you will know your fuel consumption, how much fuel you are consuming from going A to B. So the basic four elements of navigation can be distance, speed, time, and direction. So over here we have four main directions. They are called cardinal: north, south, east, and west. Apart from these four main directions or cardinal directions, we have another four quadrantal directions, which are northeast, northwest, southwest, and southeast. So these four directions are called quadrantal directions, and north, south, east, and west are called cardinal directions. So the correct option is northwest correct, southeast also correct. So the right option will be option C, all of the above. Next, what is gratitude? Gratitude is the network of meridians and parallels on what? So the definition of gratitude is given to you. Often the definition is asked in exam, but now in this question they have given you the definition and they have asked us something else. So they say this gratitude, which is the network of meridians and latitudes. Okay, we draw this network on what? Is this network available on the earth, maps, or any other thing that we use? So the correct option will be maps. On the earth, when you look at the planet earth, we don't see longitudes in the sky, meridians or latitudes. These are imaginary concepts or imaginary lines. We can only draw these latitudes and longitudes on a paper, map, chart, but not on the earth. So correct option will be maps. Question 7. The maximum difference between geocentric and geodetic latitude occurs at what latitude? So the maximum difference between geocentric and geodetic latitude as given in the textbook is 45° north or 45° south. Okay, 45° north or 45° south. Next question, and very important question this is. Okay, so don't miss out this question. Remember this question for exam. It can get asked. Ratio of the ellipticity of the earth is 1 by 297. If the major axis, here they are talking about equator. is 6956 kilometer. What is the minor axis at the poles? Just now we saw previously that due to the compression of the earth, we have flat poles but equator a bulging equator. So equator bulging on its two sides, but at the poles, both poles are flat from the top and the bottom. Okay, and due to this, the measurement along the equator will be more than the measurement at either pole. So now in this question they have given the difference between both of these measurements is 1 by 297. That means if equatorial diameter or equatorial axis is 6956 kilometer, so what will be the polar axis measurement? We know that polar will be lesser than the equator, so our answer will be something like polar axis equals to equatorial axis less than equator by how much? By a difference of, as given in the question, 1 by 297 of what? Of equator axis. 1 by 297 times equatorial axis. So let's put the values. 6956 minus 1 by 297 into 6956. Okay, 1 by 297 is the difference between the equatorial axis and the polar axis. So 6956 minus, when you divide this, you get 6956 divided by 297, 23.4 something. So let's consider 23. So 6956 minus 23 will be 6933 kilometers. So that means the measurement of the polar axis will be equal to 6933 kilometers. So correct option is option number Charlie. The closest option is option Charlie. Let's go to next question. A great circle is any circle on the surface of the earth whose, so we have to define this great circle, whose radius is same as that of the earth, whose plane passes through the center of the earth, or both. So by definition, the correct option will be option number Bravo. So by definition, the option will be Bravo. A great circle is any circle on the earth whose plane passes through the center of the earth. Next. The shortest distance between any two points on the earth is defined by what? So just now I said, when you follow a great circle route, you are actually flying a shortest distance between 2 points. So the shortest distance is defined by a straight line joining the two places on a map. Wrong. The shorter arc of the great circle joining the two places, that is the right. So on the surface of the earth, so you take an entire great circle. Let's say this is your great circle. Okay, and your points are located at A and B, and you are going from A to B. So you have to consider along this great circle, you have to consider a shorter arc connecting A and B. So there are two directions you can follow from to go from A towards B. You can either start like this and go anti-clockwise directions and reach B like this from here anti-clockwise, or you can fly clockwise and go from A to B like this. So there are two ways. So out of this, the first way and the second way, the shortest way will be, the shortest distance will be given by way number 1. Okay, that is the shortest distance. If you fly like this anti-clockwise, look at the distance, much more. Okay, so by definition, it is the shorter arc of the great circle connecting those two places. Question 11. What is a meridian? Is it a semi-great circle? Is it a line joining places of the same latitude? Is it a semi-great circle joining places of same longitude? Okay, joining places of same longitude. So by definition, definitely just a meridian is not a great circle. Meridian and anti-meridian together, a meridian and anti-meridian together will form a great circle. That means only a meridian will be called half a great circle. So that means both are half of a great circle. Together they will form an entire great circle. So the correct option will be a semi-great circle, as for definitely that, joining places of same longitude. So that is correct. So on the surface of the earth, let's say we have a longitude of, let's say this is 20 degree west. 20 degree west. So all places, locations along this 20 degree west will be joined by this meridian. Okay, so meridian is a place or is a line joining all places of same longitude. Longitude is the position. Meridian is a line joining all places falling on the same longitude. Okay, so option number C will be the correct option, semi-great circle joining places of same longitude. Question 12. For measuring latitude, the datum used is what? So let's, very simple question. This is your earth. We have North Pole, we have South Pole, and then we have equator. Now the latitude of equator is what? It is 0 degree. The latitude of North Pole is 90 degree north, South Pole is 90 degree south. Okay, that means your equator is the starting point with respect to latitudes. So when you have to measure latitudes or label them, your equator will be the datum or will be the starting point. So going northwards, you will have 10 degree north, 20 degree north, so on and so forth up to 90 degree north. Starting in the southern hemisphere, we have 10 south, 20 south, 60 south, so on and so forth up to 90 degrees south. So with respect to latitudes, your equator is the datum or the starting point. With respect to longitudes, your prime meridian or 0 degree meridian will be your starting point or it will be your datum. Question 13. Latitude is expressed in degrees, minutes, and seconds to the north or south of what? Just now I told you. So this is your equator. Any latitude to the north of the equator will be called northern latitude. Any other latitude to the south of it will be called a southern latitude. So correct option will be equator. Equator is your datum. With respect to that, your latitudes will be numbered. Question 14. Rumline is a curved line on the earth cutting successive meridians at the same angle. It is concave to the equator, convex to the equator, sometimes concave, sometimes convex. So look at this diagram. So we have the earth. Okay. This is your equator, 0 degree. These are your two places. Place A, place B, North Pole, South Pole. Just now previously I told you, when we have to go from A to B, the great circle will give you the shortest distance between them. And due to the shape of the earth, which is bulging at the equator but compressed at the poles, it is very beneficial to follow a route which passes through the nearest pole compared to a route which passes along the equatorial or around the equatorial plane, because in the equatorial region we will have to cover a longer distance between two longitudes compared to the same distance at the polar regions or somewhere at top latitudes, right? So for example, this is your meridians passing through A and B. Okay, now this two meridian is same, 10 degree east, 10 degree west, 10 degree east. Now look at the distance between these two meridians at the equator. It is that big. But when you go towards northern direction, and the same distance between these two longitudes will be only this much. So you can clearly see this distance near the equator or at equator is bigger than this same distance at polar regions, right? So that's why it's beneficial to follow a route which passes through the pole, North Pole or South Pole, because it will take you to your destination much faster and earlier. So connecting these 2 points A and B, Always a great circle will pass through the nearest pole like this, okay, shortcut, but a rhumb line will be towards the equator. So this is your rhumb line which is closer to the equator. This is your great circle which is closer to the north pole. Okay, so that's why great circle are always towards, okay, the tendency is always towards the nearest pole. For a rhumb line, it is always towards the equator. Okay, remember that. Now the words they use here is for closer, they use convex, away, away from something, that means concave. So remember these synonyms. Closer means convex, away from something, from equator or away from pole, that means concave from that. So now over here they are talking about rhumb line. So I know that rhumb line is closer to what? To equator. Rhumb line is away from the nearest pole. So that means let's look at the options. Concave to the equator. So concave means what? Concave means away. So is it away from the equator? No, it is closer to the equator. So this is wrong. Convex to the equator. Now what is the meaning of convex? Convex means close, closer. So yes, rhumb line is closer to equator. So they have expressed this statement as convex to the equator. So this is correct. So option number Bravo will be the correct option. Next question. The only line on the earth, the only line, which is both a great circle and rhumb line. So that line is only and only your equator. Meridian. So we saw that meridians can be meridian and anti-meridian together can form a great circle, but not a rhumb line because directions change when you cross a north pole or a south pole. Okay. Uh, Equator is the correct option. Option C is wrong. So equator is the only latitude on the earth which is both rhumb line, or is the only line on the earth which can be both great circle and a rhumb line because it has constant easterly westerly direction, so it satisfies the definition of a rhumb line, plus equatorial plane of the earth, so same center of the earth, and also divides the earth into two equal halves, north and south, so also satisfies the definition or requirements of a great circle. Therefore equator can be called both a great circle and a rhumb line. Question 16. The datum for measuring longitude is the prime meridian, not the latitude, but the prime meridian or Greenwich meridian or 0 degree longitude. Next, the maximum latitude can be. So latitudes is beginning from equator, going to the north pole at 90 degree, going to the south pole at 90 degree. So the maximum latitude available is 90 degree, and the maximum longitude that is available is 180 degree. 180 degree in the eastern hemisphere, another 180 degree in the western hemisphere. Together 360 degree. Question 18. Parallels of latitude, okay, and meridians on the earth can be distinctly identified when map reading are imaginary lines and so are not marked on the earth. Only global satellites can identify them. So latitudes and meridians are imaginary lines and are not marked on the earth. Question number 19. Very simple to understand this. I have just stated the same statement in the previous questions in the beginning. For the graticule, that is, graticule is what we draw on the map or the chart. But in reality, we don't have meridians or latitudes on the earth. We don't see them in the sky. Question 19, we have to solve this. Point A is 20 degree 30 minutes north. Point B is 41 degrees south, 30 minutes south. If aircraft is traveling from A to B, what is the difference in latitudes between them? So look at this diagram. So always better to draw a diagram. This is your earth, this is your equator. When you are dealing with latitudes or solving numerical, dealing with latitudes, always draw the side view of the earth, which is like this. So this is your north, this is your south. Now in this example, your location A is in the northern hemisphere, 20 degree 30 minutes. Location B is in the southern hemisphere, 41 degree 30 minutes. Now that the rule of thumb is that when both points are in the same hemisphere, you subtract the difference between them. You subtract the difference between them. When points are in different hemispheres, you add the difference between them. You add the difference between them. Okay. So remember this. When points are in the different hemispheres, you add the difference between them, because for the only reason that there is a 0 degree latitude between them. So you have to add. Otherwise, you have to subtract. So first, let's write this. The D lat between A and B equals to D lat between point A and equator plus D lat between point B and equator. So the D lat between point A and equator is how much? 20 degree 30 minutes minus 0 is 20 degree 30 minutes. Difference between point B and equator. 41 degree 30 minutes minus 0. The difference between them is 41 degree 31 minutes. 30 minutes correction. So now addition. So it will be equal to, use your calculator, 20 degree 30 minutes plus 41 degree 30 minutes, 62 degrees. 62 degrees. Okay, that is the difference. And now it's mentioned in the question that you are traveling from A to B. So A to B, like this. A to B. So what direction are you flying in? You're flying in the direction of south. So D lat equals to 62 degree south. 62 degree south. Okay, the difference is towards south. It means that. Next question, last question for the day, question 20. Earth is a planet, a satellite, or asteroid? So clearly, very simple. Earth is a planet. So what is an asteroid? A small rocky planet orbiting the sun. We are not that small planet orbiting the sun. A satellite, any artificial object placed in orbit around the Earth or another planet to collect information or for communication purpose. So we are neither that. So neither asteroid nor satellite. So the correct option will be Earth is a planet. With this, we come to the end of this lecture. I hope it was very productive for you. You have learned something new today. Quick recap of this lecture is that we understood why the Earth chapter, though very simple, but it forms the basic foundation for understanding the next chapters of convergency, departure, rate circle, and drumline. Distance being an important element of navigation, knowing the shape of the Earth, characteristics of a great circle, and drumline are very important. After that, we saw how to calculate the difference between two latitudes in different hemisphere and same hemisphere. The same logic applies to longitudes. If points are in different longitudes, add; in the same longitudes, subtract. After that, we looked at latitudes, we looked at longitudes, okay, we looked at graticule, the what is the datum for latitudes, what is the datum for longitudes. So these basic facts you have to remember always. Okay. So in this chapter, you are going to read this basic information from chapter number 1 of Oxford. So highly recommended to read that chapter. Along with that, the very important question that is often asked is the ellipticity. So we calculated the polar axis diameter from the equatorial axis. The difference between them was 1 by 297. Okay, so we know that equator is bulging at the bulging, but poles are flattened. Okay, so this shape of the Earth is called oblate spheroid, and therefore equatorial distance will be much more than equatorial polar distance. Okay, and that's how by this logic we solve that numerical. So let me know your more questions, any more doubts that you have in the comment box. Do hit the like button if you have liked the lecture. I will be very happy if you have liked this lecture. Subscribe to this channel definitely so that you keep getting timely updates, and share this video with everyone so all your friends get the benefit of this. All the best. Don't miss the next videos. Keep revising. Keep in touch. Thank you.